stem anatomy. You saw a little bit of this last week as well. So I'm going to draw a stem of a plant using the Paint app. Hopefully this works. We're going to make the stem brown. And I'm going to use a pencil with a small thickness. So the key for making a stem is just make a branch pattern, like so. 2 lines, try to bring them closer together. And that is the stem. And now the next thing I'm going to do is first close off the bottom. And I'm going to make the terminal bud green. Terminal means on the very end. Right now, these are the buds that are opening. Inside them is the thing called a meristem. And then along the sides of the stem, if you look, are things that I didn't realize till I started gardening are all the same thing. I'm going to make some little marks with gray. And then I'm going to fill this in. So now you can see those. Those are nodes. They form wherever leaf scars usually are on a woody branch. They're also called axillary buds. If I were to cut off this branch right here, and I'll make it red. If I were to cut off this branch right there and remove all of that, the next bud will take over growth and become the new terminal bud. And the growth would actually go in the direction the bud is pointed. So if I were to cut even lower, right here, the bud will grow that way. And that is one of the ways that we prune trees. But we're going to undo some of that. And we'll undo that cut. All right, so the terminal bud is right there. That's not a good color to use. We'll draw the line. So the terminal bud is right there. The nodes are all of these things, also called leaf scars. And I'll make the inner node key a slightly different color. We'll go for blue. Inner nodes are the gaps between the buds. So that's why they're also called nodes. So one of the things to take from this is nodes, leaf scars are also axillary buds. It's one reason why, like after the snowstorm last week, it didn't kill the trees. It's just going to change the way some of the branches grow for a while. So that's it for your stem anatomy. For the next part, I'm going to go and we're going to look inside the terminal bud right there. To do that, I'm going to use a Brussels sprout, which happens to show what's inside a terminal bud. Part of learning about plants is learning about the meristems. Those are the tips of all growing plant parts of dicots. I can't show you that because we don't have access to a microscope right now and you're not in the lab. The good news is if you have a Brussels sprout, you can see the cross-section of a meristem because a Brussels sprout is nothing more than a giant meristem. So to see it, carefully cut a Brussels sprout in half. And now I'm going to zoom in as best as I can. So, if you look at the cross-section of a Brussels sprout, you will see a leaf and a gap, and a leaf and a gap. So, this is great because this right here is the stem. All of these leaves are leaves. At the base of the leaf is a leaf scar, and it's also called a node. When plants are growing, if wherever a leaf falls off, that can be the site of a new branch, called a node. There are spots between the nodes. Those are called internodes. So we have node, leaf, internode, stem. I'll say it again. Node, leaf, node, internode, stem. And all of this bundled pile of tiny little baby leaves would be the true meristem. This is the site of growth on a plant. Most plants do not have a meristem this big, but fortunately we have the Brussels sprouts today. I'm going to now finish chopping these up so that I can fry them in some bacon grease, which makes them delicious. So one more time. We have leaf. The base of the leaf is the node, or leaf scar, you can call it the same thing. And the gap is the internode. But I need some more Brussels sprouts for the bacon. So we have leaf, leaf scar, which is also the node, and the gaps between it are internode. So, have a good day. Inherited picture online of a meristem photographed through a microscope. This is that growth tip. As you can see, it looks a lot like the Brussels sprout. Primordium just means future. So, just to draw on here, and I will draw in purple so it doesn't match. So, when they say leaf primordium right there, just know that's a future leaf. This right here is another future leaf. I'm going to use light blue now. Actually, no, we'll go for red. So this area right here is the internode. And then that tiny little section here, which I'll circle in black, is the apical meristem. So you can either cut apart a Brussels sprout if you have one, or copy this diagram. Words that you don't need to know for this class are protoderm, ground meristem, or procambium. You should know the apical meristem as well as the leaf primordium. But just know that's a future leaf, and you can also see the internode right there. So this is the internode. This is the meristem right up here. And I'd recommend you just pause the video right here and copy this diagram. You understand what apical dominance is. Trees are growing up. They're growing away from gravity and towards the light. All plants are trying to grow towards light and towards gravity with their leaves. So apical dominance, you can see this in almost any tree, but you'll best see it in pine trees. So we're going to draw a happy little tree. But we're going to draw it rather poorly. And you'll see this especially with things like spruce and fir trees here in Colorado. If you look at this, you'll see the top of that tree is kind of winning. As you look down, the branches get steadily wider. The reason why is because of a plant hormone called auxin. Auxin regulates mitosis, causing plants to grow. And so this is what allows plants to grow that way, because way up at that top meristem is kind of the mind control of the entire plant. There is an auxin surge there that is causing the very top to grow the fastest, but it's also causing all of these secondary branches to grow a little slower. So, and as you've already figured out, I'm an obsessed gardener. So one thing that you can do with this is you can manipulate this to change how your plants look. As gardeners, and just remember, auxin is the plant hormone. We're just going to erase that. As gardeners, like, we're constantly shaping our plants. So let's say I decided to just cut off the top of this plant. And there is no eraser that I can find. So we will cut it off this way. If I were to just cut off this plant right here, it's not going to kill the plant. What it will do is it's going to take away that auxin. And when that auxin goes away, I can get rid of the rest of the plant this way. So we're going to get rid of all of that plant. And now the dominant apical meristem, the apical dominance, is gone. What's going to happen now is pretty cool. The plant is going to start growing from all of these side shoots, like that. and it's going to get full. Gardeners, we call this pinching back. If you do it with a shrub, and I'm trying to pester my friend Chase to let me go shape some of his shrubs because the shrubs in front of his house look terrible right now. By doing that, it's going to cause this plant to grow really thick and full. This is the trick for shaping hedges. You're manipulating apical dominance. Apical dominance is a really cool evolutionary advantage because if you imagine a tree growing in a forest, if all the big trees around fall, the remaining plants have to race to the sunlight, and whoever grows the fastest will win that race. So that is apical dominance. All right, so here we're just going to go over some more stuff with stem anatomy. You've seen some drawings, now you're going to see a few PowerPoints. So here again is the meristem, the growth tip of the plant. And the big thing to take from this is just paying attention to the entire concept of the new leaves, the meristem right there, and these internodes. And then the root also has a meristem as well. These are the growth tips of plants. Apical dominance, as you can see in this Norfolk pine, that very tip, meristem right there, is suppressing the growth in this entire zone. And as you get farther, you'll see the tree is growing farther and farther out because there's less suppression or slowing down. The hormone responsible is auxin. It speeds up the growth of the top of the plant, but slows down everything around it. And this is why pruning works. When I first started gardening, I never wanted to prune because I thought I was hurting the plants. Now I understand that when you remove that meristem right here, the rest of the plant grows a lot faster. Here is the plant unpruned. Here's the same plant a little while later if you prune it, and you'll see it grows bushier. So as a gardener, I often do this, especially with my shrubs. Tropism is how plants respond to different environmental things. Gravitropism is its response to gravity. Here, and you can do this with a plant, if you started that seed in the pint glass that I showed you last week, if you tip it on its side right now, as long as the soil doesn't spill out, and leave it there, you can actually mimic this. You'll get the roots to turn 90 degrees and start growing straight down again. But you also can see with this tomato plant, it starts bending upright. The hormone responsible for this as well is auxin, which determines the rate of cell division in plants. Phototropism is how they grow towards light. And those little purple dots represent auxin molecules. If the sun is at all off center, the auxin accumulates on the dark side of the plant, causing that half of the plant to grow and divide faster, making it bend over this way. Here you can see it happening with little seedlings. This is why if you're starting seedlings in your house near a window, you'll see they start leaning towards the light. And that is one problem, because if they're leaning too far, they'll tip over and die. If you made the plant maze, this is how the plant maze is going to look in a few more weeks, probably. I'm going to be opening up mine just to check to see if it needs some water, probably tomorrow. But this is all done through auxin and phototropism. Stem elongation is the other thing, which I'm going to make some videos of later this week. It's also called bud break. Wood branches are only going to grow longer in their first year. After that, they will grow thicker, but they won't grow longer. A common question you'll sometimes see on tests is if you put a birdhouse 5 feet off the ground on the tree trunk, where will it be in 10 years? It will be at the same height, because the trunk doesn't grow longer unless it's bamboo. And no one puts birdhouses on bamboo. So with real trees, wherever you mount something on a tree trunk, it's going to be there. It's not going to get taller. When you see birdhouses that are 15 feet in the air, like the owl house in front of our place, that's because we climbed a ladder to hang it at the right height for owls to nest in there. So if you go start looking at the trees outside right now, they're a little bit frost nipped from last week, but you will see the stem elongation happening. You'll also see these hoaxes. There's one right by in the town where I grew up, where there's a tree about 15 feet in the air, and they convince everyone that someone chained the tree or chained the bike to a tree when the tree was young, and the tree lifted the bike up. The way a bike ends up this tall or high up in a tree is because someone climbed up on a ladder and put it in the branches, and the tree grew around it. The tree will not lift your bike off the ground. the growth. And what you will see with plant growth and elongation is, and I will make this red, is this is a growth shoot right here. Once I get the right brush, there we are. So this is going to grow that way. This one right here is going to grow in this direction. And all these are going to grow longer. In the case of things like crab apples and a lot of the trees you see around here, elongation is really fast because we only have a few weeks where elongation happens. Things like apple trees, those little buds that you see right now could be upwards of 12 inches long by the end of the month or end of June. Other things like cottonwoods and redbuds, their elongation can be over 2 feet in the course of the growing season. One thing is when trees have rapid elongation, the wood tends to be weaker. This is one reason why the city of Fort Collins won't plant cottonwoods anymore, because they grow really fast, but as a lot of you saw last week in the blizzard, the wood is very weak, and when heavy snow builds up in the branches, it rips the trees apart and can damage cars and hurt people if it lands on them. So that was your lesson on stem anatomy and elongation and tropism. Thank you very much.